Okay, autopilots for your drones. So here we have an older APM autopilot, but I think you can still buy them about up to 2.7. You can get them from places like Banggood, I think, or Hobby. I'm not sure if Hobby King still sell them. This is Arducopter. It's called APM because it's Autopilot Mega. I think the M was a Mega, the chip that was actually on the board. This one, the board is inside. It's just got this plastic cover on the outside there. Just to show you really quickly the system, and then I'll show you something a bit more sophisticated, which I probably would recommend buying, called a Pixhawk. But this would still work quite well. And you can put these on your ground rovers too and do some GPS navigation on the ground or in a boat as well. So there's my receiver, which we know about by now. Coming into my inputs, so I'd have my PWM outputs here for my 4 channels: throttle, aileron, or roll. I shouldn't call it aileron because it's a drone, but roll, pitch and yaw. Your documentation will tell you exactly which ones to plug them into. I'll just choose any for the moment, for the purposes of this demonstration. So I have 4 coming out from my receiver, 4 going into my inputs, 4 coming out from my outputs, going into my 4 arms for my quad rotor. Okay, you can see for my outputs, it's going into my speed controller, plugs into my electric brushless motor. Just there. The speed controller, it would not have this particular plug on it. That would be hardwired into what's called a power distribution board, PDB, which is sitting in the drone. That would be hard soldered into the PDB, power distribution board. But I've just got this example 25 amp speed controller here that's got a plug on it. So that's very simply what it looks like. Inputs from your receiver, it picks up the signal from the transmitter. Pilot commands, let's say, pitch. Signal comes into the receiver. Receiver goes, pilot has commanded pitch, passes that to the flight controller board. That's passed through and passed out to the drone. Input and output. Also in here you've got GPS, so your GPS receiver would plug into here. Sorry, correction, GPS antenna, because the GPS module is on the board. So the antenna will plug into there. That's what a GPS would look like. Excuse the blue tack. Okay, you mount that up nice and high away because it's affected by magnetism as well. Inside the GPS module is a compass, by the way, and it's affected by magnetism, so you just wouldn't mount it next to an electric motor, obviously. GPS plugs in there. Any sort of telemetry data would plug in there, and you would have a power module which would power this. I think these are 5 volt, I'd have to look it up, and you'd have 5 volts coming in to power this up. You would have that mounted nice and level. It says forward, so that's to the front of your aircraft that way. You can put them at different orientations, but you have to tell your software that they are in different orientations. The Autopilot has got gyros and accelerometers on it. Gyros measure rate of roll or speed of roll, about those roll axis and the pitch axis, and the yaw axis. So they chips on board, and accelerometers measure acceleration. And that's about all I need to say about that. Let's go to the Pixhawk, a bit more sophisticated. Okay, there is the arrow pointing forward. Okay, say forwards away. There's your GPS. Again, it's mounted in the correct orientation. I'd have that mounted away. And it's got a magnetometer, which is a compass on board, which can give me directional heading for accuracy as well. Hence, that's why we mount this as far away from all the electronics as possible. Let's plonk that down there. We have our different settings, different plugs here. a switch to turn it on and off. I'll show you that on one of the bigger drones. Telemetry can come in here, USB connection. My power comes in here. Again, I supply 5 volts through this into this. 12 volts are going out to my motor, so I'm picking off 5 volts. GPS will plug in just there. It's fallen out, but that will plug in like that. Thank you very much. And I have my inputs coming in from my receiver coming in here. This doesn't accept, I mentioned in a previous video, PWM. For this particular Pixhawk we use PPM, which is all your different signals for roll, pitch and yaw coming in on one line rather than 4 separate lines. Okay, that will come in, that comes on one line there, and I'll show you that on the big drone. Aside from that, it's the same setup as this one, just more sophisticated, faster processing, more memory. USB connection just there, USB connection just there for plugging into my computer, downloading my waypoint file onto it. Got it mounted on anti-vibration because autopilots hate vibration, so you want some sort of dampening grommets, whatever there. So Pixhawk Autopilot, APM Autopilot, and there's different brands, capable of downloading waypoint navigation to it for mission planning. The control of that is you would allocate a switch on a receiver. It might be this particular switch here, so that's in stabilized, might be in stabilized mode, so the drone is just hovering. I might go to stabilized mode, it's hovering but it doesn't have GPS, so even though it can maintain its orientation in roll and pitch because it's got the gyros and accelerometers on it, it'll drift away with the wind. So I can put it into loiter mode, which means it's already acquired its satellites, but its positioning will be governed by the satellite, so it'll hold station there even in quite a strong wind. You'll hear it, you'll hear the motor throttling up and the thing angling like this as it struggles to hold position in loiter mode. And I can go into fully autonomous mode. Well, I shouldn't really call it fully autonomous because it's not fully autonomous, but it'll head off into its waypoint navigation. So I flick it from down into autonomous, it'll turn, head off to its first waypoint that I've programmed into the mission planning software that I've downloaded to the memory on the chip. And then hit the first waypoint, turn, head off to the next waypoint, turn, and execute that. Perhaps it's a lawnmower search pattern to find a lost bushwalker. And waypoints also can vary in altitude, and you can also do things at waypoints, like I could get it to, once it gets to a certain waypoint, get it to move a servo to deploy a payload. Okay, so that's the autonomous system.